Hello friends, welcome back to my channel. This is Vinay Chakar having 9-year experience in iOS. So the today topic is what is QoS in GCD, Grand Central Dispatch, and difference between GCD and NS operation. So moving further on the video, once Steve Jobs says that design is not just what it looks like and feels like. Design is how it works. So moving on the video. Topic we will cover on this video are what is GCD, what are the different QoS level, NS operation and Grand Central Dispatch, benefits of NS operation and summary. What is GCD? When it comes to multi-threaded and concurrent programming, Apple provides us a simple solution called Grand Central Dispatch (GCD). GCD is built on the concept of queues. You submit a task into a queue and iOS fires off a separate thread or uses an already running thread to execute your task's code in the form of closure. Queues come in concurrent and serial flavor. Serial queues execute task one by one in the order submitted. Concurrent queues try to run task in parallel if system resources allow it. What are the different queues level? GCD offers global queues with a different queues level. Global queues are concurrent by default except the main queues which is serial. Dispatch queues is the quality of service which determines the priority required for the task in the thread. As you can see, there are different priorities level available. Background has the lowest priority and user interactive has the highest. User interactive. The highest priority is reserved for work on the main thread like updating the UI, etc. User initiated. This is the case when a user taps a button on the screen and that leads to code execution. Think at IB action and the results are immediate. Utility. This is when you process some data, relatively fast downloads, etc. in the range of 10 seconds maximum or so. Background. Any file system, cleanup tasks, long network downloads, syncs, data indexing, heavy image processing, etc. So, in the detail, we can categorize QoS class, type of work and focus of QoS, duration of work to be performed. First is user interactive, work that is interacting with the user, such as operating on the main thread, refreshing the user interface, or performing animations. If the work doesn't happen quickly, the user interface may appear frozen. Focuses on responsiveness and performance. Work that the user has and performance. And duration of work to be permitted. Work is virtually instantaneous. Second is user initiated. So it work that the user has initiated and requires immediate results, such as opening a saved document or performing an action when the user clicks something in the user interface. The work is required in order to continue user interaction, focuses on responsiveness and performance. Work is nearly instantaneous, such as a few seconds or less. Utility. So, utility work that may take some time to complete and doesn't require an immediate result, such as downloading or importing data. Utility tasks typically have a progress bar that is visible to the user, focuses on providing a balance between responsiveness, performance, and energy efficiency. Work takes a few seconds to a few minutes. Background. Work that operates in the background and isn't visible to the user, such as indexing, synchronizing, and backups, focuses on energy efficiency. It work takes significant time such as minutes or hour. So QoS class and description like default, the priority level of this QoS falls between user initiated and utility. This QoS is not intended to be used by developers to classify work. Work that has no QoS information assigned is treated as default, and the GCD global queues runs at this level, unspecified. This represents the absence of QoS information and cues the system that an environmental QoS should be inferred. Threads can have an unspecified QoS if they use legacy APIs that may opt the thread out of QoS. So when you use global queues, there are almost no surprise exits. You can submit a task in a global queue, choose a priority, and it works as expected, like dispatch queue dot global qs dot utility dot async and your code block. But of course, you can create your own queues. And here comes a trap. Even if you choose a QoS label and think that system will honor it, this is not the case. For example, let my queue equal to dispatch queue, label my queue QoS dot background and attributes dot concurrent, my queue dot async. And in the code block, do some work that user is initiated by tapping a button. What will happen next? If your code block involves execute some code when a user tapped a button, when iOS will silently upgrade your queues level from background to user initiated, and you can't do anything about that. That may lead to janky and unresponsive app behavior in some cases, and you don't want that. So, how to avoid that? Use global queues or meticulously plan which task you submit to which queue to avoid priority changing. iOS is smart enough to manage execution for you, and mostly everything works well. NS operation and Grand Central Dispatch. You might have heard about the terms NS operation and GCD. Let us understand what they are and when to use them. Both NS operations and GCD allow executing heavy computation tasks in the background on separate threads by freeing the UI application main thread. GCD is a low-level C-based API interact directly with Unix level of the system. NS operation and NS operation Q are high-level Objective-C classes. NS, NS operation Q is Objective-C wrapper over GCD. If you are using NS operation, then you are implicitly using Grand Central Dispatch. That means the NS operation API is a higher level abstraction of Grand Central Dispatch, which makes NS operation slightly slower than GCD. Always use the highest level abstraction available to you and drop down to lower level abstractions when measurement shows that they are needed. But many developers prefer to use GCD over NS operation unless extremely necessary. Implementing GCD is lightweight compared to NS operation. Benefits of NS operation: you can pause, cancel, resume an NS operation. With Grand Central Dispatch, you no longer have control or insight into the execution of that task. The NS operation API is more flexible in that respect, giving the developer control over the operations lifecycle. You can set up a dependency between two NS operations. This is a powerful concept that enables developers to execute tasks in a specific order. An operation is ready when every dependency has finished executing. Can monitor the state of an operation or operation queue, ready executing or finished. The NS operation and NS operation queue classes have a number of properties that can be observed using KVO, key value observing. This is another important benefit if you want to monitor the state of an operation or operation queue. You can specify the maximum number of queued operations that can run simultaneously. When you want more control over queue, all above mentioned, use NS operation. And for simple cases where you want less overhead, you just want to do some work into the background with very little additional work, use GCD. So friends, thank you for watching this video. I hope that you learned something new here. Please comment below if you want download link for this PPT. So I will provide it on description box. So friends, thank you for watching this video. If you like this video, then please like, share and subscribe the channel for getting the future informative videos and updates related iOS development. Thank you.